How's it going, everyone? Welcome to this Microsoft Excel tutorial with Eli Dugan. Today, I'll show you how to use Excel in a math context. If you're taking calculus, you may at some point need to solve a differential equation. They can sometimes be a pain, and sometimes you don't actually need an exact solution. If you only need an estimate for what the value of the function will be at some x value, or if you just want a general sense for the function's behavior, then you can use what's known as Euler's method. Essentially, if you know the coordinates of a point that the function passes through, you can use the information about the slope at that point given to you by the differential equation to build a linear approximation of the function at that point and estimate a new point on the function that's a small step h away. This is then repeated and will become more accurate with smaller h. Right now, I'm showing you the spreadsheet that I use when I need to do Euler's method. For purposes of keeping track, I write the original equation, the original differential equation, up at the top. And in this case, I'm using a sample logistic equation that uses these parameters over here. Here, I have my h, which is currently set at 0.005, which is pretty accurate. When I wrote my EE, where I used a similar spreadsheet, I used a step size of 0.00025, since I wanted to get as much accuracy as was reasonable to get, but what we have right now is perfectly good. I also have my initial x and y values right here, and that's what these are linked to as the initial points. So the key is that in this column, I basically replicate the formula up top, but I actually pass through the y value, the previous y value, into the function, and that tells me the slope. In this case, the slope only depends on the y value. That's just the case that I happen to choose. But in equations where the x value is also used, the spreadsheet would work in exactly the same way. Just also pull in the x value and use that in your formula. The x values, then, are just iterated by adding h to the cell immediately above it, obviously using your dollar signs to lock it and make sure it doesn't go down. And then the y values use the Euler's method formula, which is to add the previous y value to the value given by the differential equation for that point multiplied by the step size. And then this graph over here keeps track of the x and y values and is currently showing a wonderful logistic curve. And that's it. Following these steps, you too can use Excel to help you with your math. Happy spreadsheeting and long live the class of 2021.